it is partly true from a different perspective. The current set of jobs that you are seeing is not going to be there anymore. It is just a matter of time before it vanishes. But you will have a different set of jobs, and for that, mathematics is really, really crucial. And that is the point I'm trying to get it across here. So that is the first point I want to make. So you don't have to really feel despondent, or really don't have to feel despair thinking, okay, once we graduate out of the college, anyway, jobs are not going to be there, so why even study? I don't want you guys to get that feeling. In fact, you have to study things a bit differently, apart from completing your academic obligations like passing the score, getting enough marks, passing in first class and all that. But you also have to do things a little bit different, so are really well prepared when you start finding the job. Okay. The second thing I want to say, it's the first thing I mentioned, is math is not the only path to career. Okay, I'm not saying everybody who wants to excel in whatever industry they want to do has to know mathematics. I mean, that's not the right statement. It is a bit stretched. But my point was, it all depends on who I am talking to and at what point of time I'm talking to. For example, if somebody comes to me today and says, sir, I actually passed the college, I graduated 2 years ago, and I'm still not able to get a breakthrough in my career. Should I have to learn mathematics? No, I won't say go and learn mathematics. That's not the right thing to say. It's like telling somebody, sir, I'm starving, can you give me a meal? At that time, you shouldn't be telling, oh no, go and learn agriculture. That's not what you should say. You should basically say, do whatever job that you could get and first get a breakthrough. That's all you should. That's all I must be saying. So similarly, since we are in college, almost everybody here in college, this is the cheapest time for you to invest. When you come out of the college, you will definitely be under a lot of work pressure, and you may not have the luxury of choosing or learning mathematics. And that's the reason why I'm saying, that's the reason why I feel this particular topic is very, very relevant to you at this stage. So don't get me wrong that I'm trying to say anybody who wants to excel or anybody who wants to really achieve something should always have to do everything through mathematics. That is not what I'm coming to. It all depends on who I'm talking to and at what point of time this conversation takes place. So since you are in college, it is really good that you strengthen your foundations. And the rest of the slide is going to be about that. Okay. So don't get me wrong. If somebody is really not good in mathematics, if you hate mathematics, it's fine. Still, you will succeed. There are a lot of other ways that people succeed. Not everybody needs to be a math nerd. Okay. So don't get that thing wrong. But it is. I mean, if you are really good at mathematics, you can really excel. But don't think that I'm making a sweeping statement. Okay. So why we need to learn mathematics? A part of it I already told you. Today, if somebody comes to me and sits for an interview, the nature of questions that I would ask would be very, very different from the type of question that I used to ask like 10 years ago. Okay. So generally for computer science students or anybody, I'm basically mostly talking about people who want to become a software engineer. Okay. So I'm not really into all this mechanical engineering, despite the fact that I graduated as a mechanical engineering. So today, since I run a company, the nature of questions that I ask would be very, very different. Okay. Some companies, they may ask questions only relevant to the type of job they are currently they have, but in general, the nature of questions have changed. 10 years ago, people expect you to know programming, object-oriented programming. They will ask you to write some Python code, JavaScript code, all that. That part is still there. I'm not saying that we don't have to learn programming and all. In fact, I would really encourage everybody to learn programming, despite most of them started using ChatGPT and other stuff. I would still recommend people to do programming. But then I at least today ask people about, do you know matrix multiplication? Do you understand calculus? A little bit of fundamentals, not really complicated calculus. I'll ask people questions about probability, optimization. These are not the questions that were asked to me when I was trying to get a job. But these type of questions have become normal these days. But if you say, no, I don't want to get into AI, ML, data science, I don't want to really be close to building systems, of course, they will not ask you. So, but if you really want to excel and leave a mark, and you want to be ahead of others, then getting knowledge in mathematics is really, really crucial. As I told you, the nature of questions, the jobs have changed, and the nature of questions are also changing. And going forward, the topic has very, very important. Okay. So you must be wondering, okay, this guy, he runs a company, and that company is also doing something in mathematics. So you must be wondering, maybe I was a mathematical nerd when I was in college. That's not true at all. I was not a topper, but I was not a poor student either. I'm slightly above average, but I didn't have a lot of 75 distinction marks and all. But there is one thing that was very different from I consider myself a bit different is I used to spend a lot of time in our library, and it is a very very beautiful library. I don't know how it is maintained today, but during my college days, I just go there and just take the books. I smell the books because we used to have a lot of imported books. Okay, that story aside, the point I'm trying to say here is I am not a math nerd. It was an accident. And the only thing that helped me become more interested in mathematics and do a lot of things in mathematics is because I used to read a lot of books. Okay. But initially, when I started, I was just like everybody else trying to get a job. Okay. That's what happened. So I decided to, after graduation, I got some offers from AutoCAD through our college, by the way. Actually, the company specializing in AutoCAD conducted some quiz program in our campus, and they selected me, telling me that you actually have a free offer to learn AutoCAD. So that's how I came here to my Chennai. I joined there, but I was not so interested. So I decided to pursue a career in software. So one day I actually had a call with my friend. I don't know how to name the guy, but I just called him. I decided to become a programmer, and he reminded me one thing. He said, of course, he didn't say that in English, but he said it in a very in a different tone. He didn't mean to insult me. He said, "உங்களுக்கெல்லாம் வராதுடா." This is what he said because he knows I'm from mechanical engineering. He didn't just say that alone. He also reminded me that I used to memorize matrix multiplication. And he said, "Dey, எவ்வளவு கஷ்டப்பட்ட matrix multiplication பண்றதுக்கு. So do you still have the courage to pursue it?" Hello? Sorry, somebody. Okay. Okay. So he told me that do you still have the courage to pursue a career in mathematics? Okay. Sorry, in software engineering. So he reminded me that the fact that I memorized C programming, C or Photon, I don't remember, but I really memorized that matrix multiplication program. It was like 20 lines. I really still I couldn't get it. By the way, people today should not have this excuse. At that time, despite the best efforts of my professor, we could not really do programming because getting access to computers is a very very hard thing to do. So please don't think that okay, it is okay to memorize computer programming even today. I'm basically telling my own experience that I didn't start my career as a mathematical nerd. That is the only point I'm trying to put across. So he somehow convinced me that I won't be able to do mathematics or do software programming. And he really cared for me. And he said, it's better you get a job in mechanical engineering. That's what he meant. And he also convinced me the fact that I'm not really cut out for doing software programming. But this probably is the best thing that has happened to me through a friend. He kind of created some sort of urgency. He forced me to learn, start from basics. So what I did was, I didn't join any institute immediately. That was because that was a fashion. People just used to, go to multiple institutes like 20,000, 30,000. They pay and then they join a course. And obviously, the course, the institute people will promise you US job or lucrative job. But I didn't do that. Okay. What I decided was, first of all, I was convinced myself that I'm really not good at software programming. So I started from basics, and that is the biggest thing and the greatest thing that I have done as far as my career is concerned. I started from the basics. Okay. So you guys may still be reading Singaravelu. I don't know about that. But back in my college days, Singaravelu microprocessor was a thing. So I started reading Singaravelu microprocessor. This was after graduating from the college. And there is some lesson for you guys also. Don't throw away the books. They are still valuable. I used a lot of books that I purchased during my college days, and I started reading them after graduation. And the first book was Singaravelu, and the second book was Balaguru Sami, and then there was another book called Yeshwant Connector from Pointers in Sea. The point I'm trying to make is when you go out of when you come out of your college, there will be a lot of interesting job offers, and you really have to be very picky and selective about it. Just because somebody is giving you a starting salary of 75,000, that alone should not be the criteria for you to to get a job. You have to ask yourself, are you really good at basics? Can you really survive a technology disruption? If you And the answer to that is you can survive only if foundational skills are really great. And you don't have to feel shy, you don't have to feel bad that you are starting from basics. That's what I have done. So I started reading Balaguru Sami end to end. And now, since I don't have the exam pressure, I didn't really skim through all the pages. I really try to understand, okay, what is this microprocessor, which was not at all needed. Nobody was saying you have to understand all this to get a job. But I did it because I really don't want, I didn't have the confidence, first of all, but I thought that is the right thing to do. And if you want to take away anything from my this session, it is something that you always have to start from basics, and there is nothing wrong about it. Okay, so this is how I started my career. Somebody told me I'm not good at it. Somebody convinced me I'm not good at it, and that somehow forced me to start from the basics. And that is the first. I won't say a breakthrough. That is the first thing I did as part of my career. And at that point, I was not in a job. Okay, so I was still trying to learn the basics. So it was really a tough thing to do because some of your friends, I mean, by that time would have got placed in a good job, but still you must be, the fact that you are still reading Balaguru Swami at that time was not a very enjoyable thing to do because of so many different reasons. You will be under job pressure. There'll be a pressure from your family, parents, and all that. But I did it anyway. That's what I just wanted to say. Okay, and at that time, the second important thing was, as I told you, just because there is a job and the offer is really good, don't just go and join. The very first job that you are going to do is going to determine your career. It's going to be the determining factor in your next 30 years or 40 years of your career. And I want to tell you how I did it. Okay, at that time there were two applications which are very, very popular. One was Visual Basic, and the other one was Power Builder, I think. And my friends were all coming up with fancy games, a lot of drag and drop based applications. And I was writing programming in C, and I would write like 200 lines to come up with a very, very small plot model. And my VB friends will just drag and drop and they'll show it to me saying, you are kind of wasting your effort. This is not what's needed. But I still persisted, and that is how I started my career. And it really paid off me in the long run. Okay, so I chose I deliberately chose to stay close to system programming, basic programming, and I most of the time initially I spent writing a lot of C code. And there are people who say that you don't have to learn programming. I am completely opposed to that. I would say you have to learn programming. And I would go one step further and say, if at all you have a choice, you must start with C. Okay, these are practical tips that I'm saying. And I'm running a company. I have done a lot of system programming, built a lot of systems, and learning C and trying to understand the memory architecture, the operating system basics. It's a highly valuable skill, and no matter whether what AI model that comes, knowing that will definitely pay off. So my point is, my friends were trying to do different things. They were like, not everybody, but most of them. And when you go out of college, you will find yourself in a similar situation. And that is the reason why I'm telling you there is a different path. You always don't have to choose the one that is easiest, but you have to choose the one that has a long lasting value. Okay, and I choose to learn programming C despite all the job pressure. Okay. So that this was a deliberate choice, as I told you, okay? Because at that time, this Y2K was very, very popular. You can just pay like 20,000. I don't know, I don't remember the exact amount, but you can pay a relatively small amount, join an institute. They will teach you COBOL programming and tell you how to fix Y2K related problems. And in 6 months or 1 year, you can go to US. That was the trend, and that was actually a norm those days. But for me to start with C, coming from mechanical engineering, was not something not everybody does, but I choose to do it anyway. So this is how I started my career. You know, basic C programming. At that time, I really don't know much, and the good thing was, since I started from the basics, I really learned, not just for the sake of learning, but really to understand. I learned everything just to make things clearer to me, not to get more scores or not to pass exams. So this is a thing that you can also do if you have the luxury of doing it, or if you are really can withstand some job pressure. Even after graduating from the college, start from the basics. There is nothing wrong on it. That's what I did. Okay. So you may ask now, okay, you seem to have done things differently. What is that you have achieved? Okay. So I'm going to play a 2 minutes video about a product called Robocompass.com. This is my product. This is my product, means my company has did the product. I'm the owner of the company, and this was my second product on mathematics. By the way, I do a lot of enterprise consulting. I work for a lot of companies, but mathematics is my passion. So I also do mathematical products. And one of the mathematical products that I did was part of India's national NCRT curriculum, is part of teacher training curriculum in many universities and many colleges. Most of them don't know my name. They use the software called RoboCompass in their schools. They don't know a person who did it is actually a Sadak alumni. I'm going to play that video, and that video is also available. When somebody is asking you, is there anything that you guys have started doing it? I mean, can you show the what Sathakian do? This is my very small contribution, to answer that. Okay. So let me play that 2 minutes video. So that will make the points I'm trying to convey in the later slides more meaningful. Okay. So can I play videos for those? Is it okay to do that?
Yeah, it's your time, Mr. Ashraf. You can do that.
Okay. So because please don't think I'm doing promotional stuff. Just want to convey one important fact. You don't have to come from Stanford and Harvard or even from IITs to really do some of the things I have done. It all just be very selective about your career and persistence. Okay. So let me play this video.
Ashraf, sorry to interrupt you, but your words are very positive, and even I would like to read again the Singaravelu and Balakurusami from today. Thanks for your like brainstorming session for yeah.
Yeah. Okay. Okay. Yeah. Thank you. I will stop it here. It runs for another minute, one more minute. But the point I'm trying to convey here is India's. Sorry, where is that slide here? Yeah. So India's third most used ICT tool is done by a Sathakian. Okay, this is not some my own observation. If you go to robocompass.com, you will see plenty of reports about how RoboCompass has been used in schools, how many books were written about it, how many peer-reviewed articles were written about it, and everybody here can just take a note that this is done by you're done by your alumni, and he's from Mohammed Sadak Engineering College. Okay, yeah. So let me go to the next slide. By the way, I mean, we have also conducted webinars in NASA, but this has nothing to do with NASA. I didn't do any research, but NASA provided a space for us to conduct teacher training using RoboCompass software in their NASA Langley Research Center. So that is also there. And I have conducted a lot of workshops on IIT and ICT also. Okay. So this is about, apart from RoboCompass, this is about how me staying close to core engineering and programming, despite the fact that I didn't come from a computer science background, how it helped me. So after working in US for some years, I joined HCL as a senior architect, and I only had 5 years of experience at that time. So from HCL, they deputed me to a lot of countries, to US, Netherlands, New Zealand, and things like that. So till now, I write code. Something my friends, sometimes they don't agree with what I'm doing. They say once you become senior, you should stop writing code. You should still be giving instruction. But that's not the way I do things. So this is my way of doing it. I still write code. Even before coming to the session, I was writing some code. Okay. So don't think writing code is something is not the right thing to do after like 10 years. That's not how I say it. So yeah, so build tools worldwide. Next. Okay. So I told you how I started my career by learning C programming, but I haven't told you how I really got into mathematics. As I told you, I'm not a mathematical nerd. I was not a topper. But what happened was I was working for a bank called AmSouth Bank, and I was the only person in that project from my company. So anything, and my company was at that time was a small company. So anything that they give, I have to somehow do it. And they gave me something called you have to implement Markov risk transition matrix. It was like Greek and Latin to me. I understood. I really completely don't have any clue what these people are talking about. But since I just went back and thought to myself, okay, anyway, I was never a software guy. Somehow we managed to do software these days because we started learning C. So why don't we start with the basics? Maybe once we understand the basics, perhaps we can even do Markov risk transition matrix. So that is how I started doing things that are mathematical related. So again, the point I'm trying to convey is if you are really close to the basics, you can really do things when the things are demanded of you. And that is how I also got into mathematics. Once I got that confidence, there was no turning back. I really became obsessed with mathematics. Any engineering problem that has mathematics, I really start loving it. But it was not always the case. It is something that happened by accident, and I just capitalized on it, and then that's how the whole thing started. For most of you, or at least some of you, this thought would have still you may be entertaining this thought. That is, whatever you say, I am really not the math person. That is the thing. That is the thing that you must be thinking. But let me do my best to see if I can remove that barrier. And for me to do it, I have to talk about some cultural issues, some psychological issues that stands between you and learning mathematics. Okay. The first thing is somehow when you read a documentary or something from YouTube or a movie or even from a book, you always get an exaggerated uh, projection about people who have done mathematics. They always project them as genius. So you immediately start thinking, okay, these people are born genius, so I won't be able to do it. That is what you will be. That was not the intention of the people who are exaggerating the genius of mathematics, but that is what you will be getting it. But that's not true always. Obviously, there are some exceptional people, but 99% of the people who do mathematics have a similar understanding problem. And they also don't understand a lot of things which you think they understand. No, that's not the case. And that is the thing that I'm trying to say here. The first is the cultural barrier. The cultural barrier is the thinking that math is not for me, or I'm taking a lot of time to solve this, so I really won't be able to do something really deep in mathematics. These are all not true. For example, don't mistake speed for intelligence. If I were to sit for an IQ exam, not IQ exam, if I were to sit for IIT exam or some other competitive exam, I don't know if I would be able to make it, because I'm really not that kind of a person who is really very quick in solving it. Okay, speed is not intelligence. I really take a lot of time, think about so many different things. But when I was trying to get a job, I really know a lot of people in my own batch who cleared all these competitive exams. And let me be very honest, I was really scared. I never attended never did any competitive these interviews, and I still haven't done it. Okay, I don't know whether after all these years whether if I'm able to do it or not, but that was not my thing. My point to you is I have done a lot of mathematics stuff. I work for universities. I work for Colorado University, Belgium University, but I am not really very speed at solving it. So don't mistake speed for intelligence. There are some people who will take a lot of time thinking about different aspects, and then finally they will succeed. In fact, when you are in job, this is the attitude that is more needed than having the ability to solve a puzzle or a Sudoku in just a matter of seconds. That's a different kind of intelligence. But don't mistake speed with intelligence, okay? And the first thing is, don't also think math is not something only selective people can do it. It is exclusive to a certain group, a certain language, certain race. That's not true. Anybody with persistence can do mathematics, okay? And that's the point I will be covering in the next few slides. Mathematics is, of course, there are people who are born with the mathematical talent. You will hear a lot of people like Newton, Gauss, and all that. But 90% of the time, it is only skill. You don't know how many years they have struggled to come up with the formula. Because when you are studying in a school book, they will have a passing reference, or you will see 2-3 sentences, okay, saying that, okay, Gauss came up with that, Fibonacci did it. But you really don't know how many years of struggle they had to undergo to really reach that point. So don't think they're all born genius, and don't think that you cannot do it. Everybody can do it with the persistence and with a lot of practice. Okay, so that's the first thing. And the second thing is, many of the concepts like negative numbers, irrational numbers, quaternions. Quaternions, probably, I don't know whether you guys have heard about it, but it is the same thing that also appears in complex numbers. Irrational numbers, everybody here might have come across. Negative numbers, obviously, everybody would have used it. But these are not things everybody understood right away. Even many scientists and mathematicians and engineers, they accept it as in the face value because it helps solve a lot of their engineering problems. If you really ask them to explain negative numbers, they may not be able to do it. It is just because it is accepted, there are certain rules around it, they take it. And you don't know how many wars have happened because of mathematical rejection of the mathematical formulas like negative numbers, irrational numbers. And that's the reason why I put this slide is, some of you may think, sir, I don't even understand negative numbers, even fraction when I look at it, or even a square root if I look at it, doesn't really make sense. This is not exclusive to you. Many scientists suffered. Even at the end of their career, they refuse to accept some basic facts and just get that thing correctly. It is not something that just because you are really not good enough, you have these doubts about negative numbers or fractions or square roots. It's a very normal thing to do. But what you need to do is, you have to accept at face value and just start applying it, thinking, well, I mean, you just have to believe yourself. Okay, one day you will try to understand the real nature of numbers, but it's not something that you will be able to really convince yourself in many of these abstract concepts. And these are very normal stuff. Okay. And as I said, the most important thing they did was they never gave up. Okay, so if you try to learn a new concept, and if you're really struggling, if you have struggle understanding it, just tell yourself, even Newton faced the same problem. This is another thing. Everybody knows Einstein's formula, right? This is E is equal to mc square. But there are instances where people sent him some lessons, some puzzles involving distance as an average, and he didn't answer it correctly, and he himself confessed it. So it's very normal not to understand everything. Okay. And the second thing was, first thing was, as I told you, every mathematician has a different side to his achievement. He struggled a lot. Unfortunately, our schools don't tell that struggle. Our schools start with the formula and give an exaggerated perception about that person, and force us to think, okay, I'm not that kind of a person. That's not true. This is about the personalities. The second thing about mathematics is, we really don't know enough history about mathematics, because we always hear Euler, Newton, Gauss, Fibonacci, Laplace. When we hear all these things, you will start thinking, okay, maybe mathematics is not for us. Maybe it is only for Europeans. Maybe it's only for Western countries. That is also not true. If you really study mathematical history, you will understand why we don't have Madhava's sign number or Aryabhata's sign number. We don't, but you always hear Laplace, you'll always hear Pythagoras, because it was a different culture. They always try to put their name whenever they try to discover something, and they want to claim credit for it. But that was not the culture in other places. I will give you a few examples. And the reason why I'm telling you is not to undermine their contribution. I'm telling you all this to know that other cultures have made tremendous contribution to mathematics, but you will not see the formulas bearing their name. But I'm going to give you a few examples. Okay. The first thing was, Newton invented calculus. No, nobody can invent a subject like calculus just like that. Everybody before him would have done some contribution. In fact, Newton himself told that I am standing on the shoulders of giants. And some of the giants were like Kerala School of Mathematics, and there was a guy called Madhava. He was actually working on infinite series for sine, cosine, and pi. This was long before Newton. Okay, what all that I'm saying, you guys can go and Google it. And how it is relevant here? It is very relevant, because mathematics is done by everybody. Every culture contributed it. Every race contributed it. It is not exclusive. Just because you don't hear those names, that doesn't mean it is exclusive only to Europeans. We have to overcome that psychological barrier. Only then we will also start thinking, okay, I also can make meaningful contribution. Okay, and I'm trying to make you think in that direction. And there is and then we all know the Cartesian coordinates, right? It was Cartesian coordinate system was discovered or invented by Descartes. That's why we call that as Cartesian geometry. We all think, okay, analytical geometry is something he invented. That's not true. Even before he did it, there was a guy called Omar al-Khayyam. He solved conic sections using intersections a lot of centuries earlier. Okay. And then we say trigonometry is a European subject because you don't have any big Indian names. But Brahmagupta is the guy who initially came up with this concept of sine. He used a term called chord, which became jab in Arabic, and the jab became a sinus in Latin, and everybody started using the word sine. Okay, he was the guy behind law of cosines. Like Pythagoras theorem, which is the foundation of all this trigonometrical stuff. Law of cosines and law of sines are also equally important. But you don't hear Al-Kashi's name, because that was not the people really didn't also put their name and try to claim credit for it. Okay, so there are a lot of other examples. The main important point is math belongs to everyone. We have to overcome that psychological barrier we should not get into the feeling that it doesn't belong to everybody or every race. Okay, so this is just as a reminder. Now some practical strategies that is going to work. By the way, I'm reserving few slides that will maybe I'll see how I can cover those areas. Some practical tips in terms of career advice and jobs and other stuff. But as I told you, I really want to I really like people getting basic stuff and allow people to strengthen their foundational skills. That is what is lacking these days, especially in a country like India, because everybody is after getting a job, and we don't have the luxury of trying to get the basics correct. Okay, now I'm going to say a few things how to get good at math. Okay, and why this is the right time for you to do it. Okay, first thing, when you are in school, obviously the only criteria that matters is you have to score high marks. So you really don't care whether you really understood, whether that really makes sense to you. If a teacher or if a book teaches you tricks, that is the only thing that you need, and you just go for it. Second thing, you always try to see which chapter you can skip, which question type you can skip. Because all these things are okay for when you are doing in school, and because of this habit, you really don't get the basics. Okay, you because your objective is to score marks, and that is why I'm saying in college you don't have that kind of a pressure. Of course, here also you need to pass, but it is really not as bad as school pressure. So you really have a lot of time to go back and understand why things work the way they are. Okay, and second thing, you don't have restriction of using your mobile phone or your laptop or library. You can just take it anywhere and read whatever you want whenever you want. So all these things make a huge difference. Okay, and that is the reason why I'm telling you college is the best time to learn foundational mathematics. Okay, and for most of us here, you must be thinking this calculus is very different. Differential equations is very hard for me to understand, or even this Fourier transform doesn't make any sense to me. But let me tell you something. These are the real problem are not in these things. The real problem is the person who says that may not really understand how ratios work, proportions work, what is exponentiation, what is logarithm, what is function graphing, what is matrix multiplication. These are things our middle school teachers or 8th standard book teachers, that's where the real gap is. Once you understand ratio, proportions, exponents, and logarithm, you can become a real machine learning engineer. We are doing a lot of ML stuff, and most of the time we deal with exponents, logarithms, matrix multiplication. We don't deal with a lot of differential equations and complex analysis. Most of the things that we do in our day-to-day life from a ML and AI perspective are these kind of mathematics. So if you think that you are really not good at mathematics, the place for you to start is your 8th standard or your 9th standard book, mathematics book. Don't feel shy about it. Go back and just start reading it. And if you think you really know good enough, then I can really ask some questions, but the time may not permit. As I told you, people have problem even calculating percentages, ratios, and proportions. Okay, that's where the real gap is. So this is just a reinforcement of what I said earlier. So go and start with the basics. I will also recommend you another book called Super Simple Mathematics. These are practical books. I bought like 10, 20 copies of this and distributed these books to some of my engineers. So all that I am doing here and telling you to do is something that I have put in practice, and I really found a lot of value in doing so. So this is not some theory-based stuff. Most of my guys in my office, they all have this book. It is around 1,200 rupees. It's a very like 200-page book. He will teach you with a lot of color diagrams. So you will understand angles, exponents, logarithm, how they are inverse of each other, what is function graphing. The problem is, when you are in college, you don't deal with function graphing. In fact, you will be really shy of asking question on function transformation, because you're afraid of being judged. You will never ask this question to a professor. But let me tell you, you have anybody who is really not good at mathematics, they have problem with basic algebra. They don't have problem with calculus. They don't have problem with number theory. In my own experience, if you are really good at mathematics, middle school or high school mathematics, you can really be a very good engineer who can do a lot of mathematics related engineering, okay, based engineering. So this is a small test for you, okay. So we do a lot of things. We try to get into a subject, really, delve deep into the subject without really having thought about even the title of the subject. For example, what is the difference between analytical geometry and geometry? You would have, everybody here might be like third year, you guys must be in third year engineering or final years, and you would have come across geometry, analytical geometry, umpteen number of times. Have you ever asked yourself, what the hell geometry, how the hell geometry or analytical geometry, how they are different to each other? How it is different? Have you ever asked that question? I don't know whether you asked that question or not. I never asked this question. And that's the reason why I brought it here. It took me a long time to really understand that thought itself never came to me. My point is, we try to understand a lot of deep things without really paying attention to the basic stuff. Okay, let me tell you, analytical geometry is just you start giving names and names, and you start expressing geometrical relationship in algebraic form, and you try algebra, that will result in geometrical solution, and you do something in geometry that will give analytical algebraic solution. So it's a marriage between geometry and algebra, and that is what analytical geometry is all about. If you really go back and read as a geometry book called Euclid, he never used any expressions, because all these expressions, the equation solving, they all belong to algebra. But in analytical geometry, people started using, putting labels on distances, points, and they started using algebra to solve it. That is how analytical geometry came to be. So it is essentially a marriage between algebra and geometry. See, don't think that why the hell I'm really discussing about analytical geometry to engineering students. My point is, sometimes we go deep into the subject without really paying attention to the basics, and that is a big gap. We shouldn't do that. Okay. The next small thing is, you all would have come across discrete mathematics. What is discrete? What is discrete about discrete mathematics? I don't want to explain it, but just go back and just see how discrete mathematics is different from learning calculus, for example. In calculus, you see a lot of continuous numbers. You deal with a lot of real numbers, which are continuous in nature. In discrete mathematics means 1, 2, 3, 4, like you will only deal with natural numbers and integers. So discrete mathematics is the whole thing about real numbers. So you will essentially study graph theory, combinatorics, and all those kind of things. The point again I'm trying to insist here is, somebody here would have even scored like 90% in the discrete mathematics. But if I go and ask, okay, can you contrast discrete mathematics with continuous mathematics? And what is continuous mathematics? I don't know. Some of you may not be able to answer that question. So the point is, just learn the basics before you dive deep into it. Okay, now I'm going to talk about what is relevant in the industry. Okay, see, everybody would have come across this Pythagorean calculating distance using Pythagorean formula, right? They also used to call that as Euclidean distance. But in machine learning, everybody talks about, at least every machine learning engineer would be familiar with at least 15 algorithms. And one of the popular algorithm is called approach is called K nearest neighbor. Okay, I'm not going to delve deep into it, but it is just a fancy name for calculating Euclidean distance, which is essentially a Pythagorean distance in using a loop. That's all it is. But they give a fancy name called K nearest neighbor. Nearest neighbor means distance. Somebody who is really the guy who is nearest to me is the one who has a lesser distance. So all that this algorithm and machine learning is doing is just using your Pythagorean distance. Now you may think, you may got some answers why I am insisting on basic mathematics, because even the most powerful machine learning models are using basic mathematics only. They may give a fancy name, but behind the hood, it is just Pythagorean, at least for k nearest neighbor. Okay, this is a very, very famous, very, very popular algorithm. And then cosine similarity. Now I can't. I mean, it is this cosine similarity is so popular, and it is everywhere. I can't overstate its importance. Everybody uses this cosine similarity in their AI and ML in one way or other. It is just your dot product. And when did you study? Maybe in ninth standard or 10th standard. It is just dot product, and it is just trying to find angle. But the point here is you must really understand it from a application perspective. If you have memorized this for the sake of passing or getting more score, of course it won't make a big difference. But if you have really understood it, then even today advanced algorithms are really powered by cosine similarity. You would have heard terms like RAG. I don't know, people who are in AI, they would have heard terms like attention, transformers, RAG, and all that. Everything is just based on this dot product and angle between two vectors. It's just that instead of two-dimensional, it is a higher dimensional vector. So let me come back to the same point. Go to the basics. Try to understand school mathematics, because most of the machine learning algorithms are based on school mathematics. Even the whole calculus, whole transformer architecture and AI is essentially based on chain rule. You will just learn that maybe when you really go out and start doing some AI. Yeah, so it's not an exaggeration to say Netflix, Google, Spotify, they all use school level maths. Of course, there are some fancy mathematics like matrix decomposition. They use matrix factorization and all that. But a fair amount of advanced algorithms are based on school mathematics. Okay, I don't know if I have enough time to go through some details. For those, where are we? How because you said some few, I need to spend some time fielding
With the
questions.
Q&A, yeah. Yeah, okay, Q&A, yeah. Because almost, yes, maybe you can take 5 to 10 minutes, then we can have a Q&A, yeah.
Okay. So, okay, let me see how quick I can do this. A small example, but okay. See, everybody would have come across recommendation system, whether it is Netflix or Amazon and things like that, right? It is all powered by the vector that you learned at +1 and +2. Okay, but there's a small difference. In most of us use vector only as a way to draw, or only as a way to describe velocity and all those kind of things. But vector is just a multi-dimensional representation of a real world concept. For example, I saw a movie, and if that movie had 5 fights and 3 songs and 4 comedy scenes and 5 historical dialogues and things like that, wow, the way the system engineers will represent that as a vector with the dimension called songs, with the dimension called fights and all that. They just start assigning numbers, and they just represent the whole of my movie seeing experience as vector. Okay, I cannot go deep into this, but the point is they see vectors everywhere, not the 2D vector that you see. Real world aspect, they just give a number and they make it as a vector, and they do matrix multiplication, and that's it. That's machine learning. I mean, in a nutshell, that's how they do it. Most of the machine learning is like that only. Okay. So I don't have much time to discuss about all this, but this some of the points I've already mentioned. And okay, I just don't want to deal with all that, but okay, this point I really want to cover. That is, see, mathematics is just a language. That is how you have to look at it. Okay, say for example, if you go and talk to a doctor, and he may write something in the prescription, he will say dermatitis, like that. Dermatitis is simply skin rash, but somehow the doctors, they don't use normal everyday English. They use the Greek to indicate the organ, and Latin to put the diagnosis or the disease. So that's how they talk about it. So dermatitis, like that, mathematician also have some specific weird way of telling things, but it's just the same thing. So they use the Greek letter for something, and they use Latin letters for something, and they basically represent the everyday occurrence or everyday conversation into mathematical language. For you, the takeaway is mathematics is just another language. And every engineer here should really learn how to read mathematical papers. Okay, when you go out, apart from preparing your resume and all that, you must also familiarize yourself and try to understand mathematical papers. And when you do that, it will all be in mathematical symbol. Important point is you may not be able to understand every math that is written, but you should be able to understand the language. Say, for example, lot of our own Tamil ilakyams, right? So literature, but they're all made in Tamil. But honestly, if you ask me, I really won't be able to understand it, but I would be able to read it. Okay, that is the first step, because that is also based on the all our Tamil letters, right? Like that, you should be able to read mathematics. You may not necessarily understand everything that is in that mathematical paper, but you need to be mathematically literate. For that, start thinking, seeing mathematics just like language. It has a different odd symbols. Okay, so you need to just start reading the symbols. Don't try to get deep into it. Just see, okay, every time when they talk about the variables, they always use x. Like that, you start digesting it. It is all just, and then you will start figuring out, okay, it is all just Greek and Latin with some symbols. Once you learn that part, then you get into specific subjects. First, try to become try to get the cultivate the practice and develop the ability to read mathematical notation. Because I have seen people who are really brilliant. They are prepared to read 500 pages of book with full English, but the moment they see a symbol, they just reject it. They hate it. But in fact, these symbols are just shorthand notation. It's just the mental barrier, some psychological adjustments that you need to make. Once you do that, you would be able to read all these advanced mathematical papers, and that is very essential if you have to really excel in your career. Yeah, this is just my in my previous slide I was telling you that, right? So there are some shorthand symbols. That is what you have to understand. Okay. So look at this. See, for example, for somebody who is really not good at mathematics, even though they don't understand it, they won't feel intimidated if they read these three sentences. But the moment they see this, they'll get intimidated. It is essentially the same thing. In fact, people who are good at mathematics, people hate those verbiage, like 4 or 5 lines. Many guys, of course, now I got trained to look at this way. I also like the later form, but I cultivated this habit despite not having a mathematical degree. I only have engineering degree, and that was we didn't used to read a lot of mathematical papers back in our college days. But I cultivated that habit, and the way and that was made possible today. I was able to read all that because I started looking mathematics as a language. It is just some shorthand notation. And once you get into that, then reading these kind of materials and literature becomes very easy. And it is, I can't overstate this also. If you have to be a good ML, AI, or even for that matter, even from other chemical engineering, mechanical engineering people, if they want to pursue a career, like research scientist or even a good application engineer, you should cultivate, you should get into this habit of reading mathematical papers, published papers. Okay, and the way that you do is, but just first of all, by thinking mathematics is just another language with some different notation. Okay, no, we don't have enough time to do all this. I will also just one small practical tip. Okay, one small practical tip. Most of us, including me, when we get a book, we try to read from page 1 to page 500 in just one sequence. But that's not the way to read a book. Especially that's not the way to read a math or engineering book. Especially when that subject is not familiar to you. Reading from page 1 to page 500 is for novels, is for thrillers. It's not for engineering and mathematics books. Don't do that. The way that you must read is, you have to first read the table of contents. Second, you only have to read the introduction of the chapter. Third, you have to just read the summary. You should not try to get deep into this at all. What you have to do is spend when you are in relaxed mood, Just go through the table of contents, introduction alone and summary alone. That will create neural hooks in your brain. And then once you have done that, just now get into the deep chapters. Never try to learn from one page to from page 1 to page 500 in one shot. It never worked, and this is not something I'm making it up. This is something from a lot of researchers and people who are specializing in neuroscience and in the art of learning. Just go through the table of contents, the 3 pages where most of us don't pay any attention. But if you just go through the table of it'll actually create a lot of neural hooks in your brain, because you'll start seeing all those small keywords, and these are neural hooks. So once you get into that real detail, it'll be easy for you to associate and remember. So just do this. This one practical tip. I do this. I tell this to everybody in my company. Okay, just please follow this. And you can just go to YouTube or other places and just see how to read math and engineering books. You will really be surprised. There is a whole science. There is whole research that helps people how to learn. So how to learn itself is a big area of study. Okay, and there are a lot of really new published papers on it. And this is one of the important stuff. They call it as a diffused mode of learning. Diffused mode. Okay, so just go and search for it. Okay, don't start getting deep into any book on the very first day. It's not going to work. Okay, these are some of these things. Okay, and if you are really good at reading books, if you really if you have the habit, or if you love reading books, these 2 books are something that I enjoyed, and it made a huge difference to me. I highly recommend this. And for people who are not into reading that much, you can just go and get a summary of these books in Tamil and English in YouTube. There are so many reviewers, so many people have talked about this book. Some of them may look very obvious to you, but it is really worth your time if you spend some time reading this book, these 2 books. Okay, this is something a rehash of whatever I already told. Okay, so this is what I do. I run a company called Provility.com. It is a 40+ member company, and RoboCompass is my another product. It's all EdTech product, but Provility is mostly an enterprise company. And recently, I built a tool called Robogebra.ai. This is a commercial application for 10th +1 +2 max students. Don't think that all the talk that I did was only to promote this product. That's not the case. It is just most of them is most. RoboCompass is fully free, but Robogebra is also my mathematical product. And recently, I applied for another startup stuff to something called Y Combinator. I haven't got it, so that's called cstepbystep.com. And there are other websites also I own, but these are the main things that I do. Okay. And lastly, a small thing about my LinkedIn. Okay, this is an interesting stuff. So back in in those days when we were looking for a job, most of my friends used Madurai Kamaraj University as their alumni, as their alma mater. I deliberately chose Mohammed Sathakian Engineering College because I was never shy of my roots. I will never be. I was always a proud Sathakian, and I want to specially mention that my LinkedIn always bore the name of Mohammed Sathakian Engineering College, even though Kamaraj University was more recognizable. I don't know about how students these days do it, but back in my days, most of my friends used Madurai Kamaraj University only. But I was very particular about this. I always put Mohammed Sathakian Engineering College. Anybody who looks, comes to me for a job, or anybody who wants to give a project for my company, whether they looked at my website, my product, they will eventually come to my LinkedIn. And I want my alma mater, Mohammed Sathakian Engineering College, to be known. This is my way of saying a small thank you to my college. Okay, and this is something that I want to really mention it here. Yeah. So that's all, folks. So I'll end it here. So yeah, if you have some questions, yeah, I'll try to answer. Yeah. Your voice is breaking.
Sir, am I audible? Good morning, sir.
Yeah, good morning. Yeah. Yeah,
I
yeah,
am
right.
Javanisha, sir, from a final year BTech student from the Artificial Intelligence and Data Science Department, sir.
Yeah, yeah, yeah. Please. Yeah.
So, my question is many engineering students learn mathematics mainly for examinations, right? As an AI and ES student, I understand that concepts like statistics, probability, linear algebra, and calculus, etc., are applied in areas like data science and machine learning, sir.
Yeah.
So, how can we train ourselves to connect mathematics with real world applications and use it to solve practical problems rather than just learning it for exams, sir?
Okay. Every day we use statistics and probability to solve real world problems. Since that's the reason why I said creating connection between industry professionals like me and like us with the students like you will help you understand how it is used in real world. For example, you mentioned about probability and statistics. You would have come across something called clustering algorithms, right? So clustering is something
Yes.
that we do in our we have something called vehicle routing problem. We want to automatically find in which zone lot of vehicle ride hiring is taking place. Okay, so we use something called zone segmentation, and this zone segmentation is done through spatial clustering. So, so the clustering concept that you are learning, and say for example the naive Bayes theorem that you are using, it is all used everywhere. Every day we are using it. It's not pure theory. I'm not saying that you said that, but it is something that we do every day, and perhaps we can have more conversations going forward. I can tell you the practical things that we use every day, so you can also immediately relate and feel convinced. Okay, this is not some abstract concept. It is an everyday thing that people use. Okay,
Yes,
I
sir.
hope
Thank you, sir.
I answered your question. I tried my best. Yeah.
Yes, sir. As you said earlier, that k nearest neighbor algorithm is nothing but Euclidean distance. Yes, sir. Actually, we have learned it in machine learning paper,
Yeah,
sir,
yeah, yeah, yeah.
in semester 4.
Right, right. So it's essentially what? It's just equivalent distance applied on a clear dimension, right? So you just
Uh,
calculate. Maybe you don't do it for just one entity. You do it for like 10,000 and come up with the one that has the shortest distance. Pick the k. Pick the k is nothing but pick five or pick 10, and then among them you choose. That's all. So end of the day, it's just Euclidean distance, right? So you know that. So the reason why I'm telling that is, as you also mentioned, it is most of them are school mathematics, like cosine similar. Cosine similarity is just trying to find angle between two
dot
vectors.
product.
Yeah, dot
Yes,
product.
sir.
Yeah. So that was my
Thank you so
point.
much, sir.
Yeah, well, my point again is basic strengthen your skills, basic mathematics. If there is one takeaway from this session, that's it. Don't try to buy big 300 pages machine learning book. Go and learn 10th mathematics and plus one mathematics or plus two mathematics. Even plus two mathematics, I consider little advanced these days. Okay, just go with maybe basic calculus and eighth, ninth textbooks, math textbooks.
Okay, sir. Thank you so much, sir.
Yeah, yeah. Thanks for the question.
Sir, good morning, sir. Sir,
Yes,
am
sir.
I
Good.
audible, sir?
Yeah, yes, sir. Yeah, yeah. Please go ahead, ma. Yeah. I don't know whether the person who is asking is a professor or a student. So I'm going to say sir because see, I use sir even for my manager, something that is not done in US, but I actually got into that habit. Yeah, please. Yeah,
Sir, yes, sir. I am a BTech student, sir.
yeah,
Name Vijay Raghunath. I had
yeah.
a question that if AI can solve equations, generate code, and even explain mathematical concepts, what unique mathematical ability should future engineers develop that AI cannot easily replace? And I am thanked for the opportunity to be in a session. This will be an eye-opening moment, sir. And I regret why I can't have this session before I start my career as an engineer. If this is in my beginner in beginnings, I will use the most of the time reading math and using it as in real world, but I just lacked it as a final year student. I just had regrets, sir. But I have to ask this question: what unique mathematical ability should future engineers develop that AI cannot easily replace, sir?
See, I really won't be able to answer. I mean, I'm glad that you understood the importance of mathematics, but you asked a very correct question. So you're asking what is the ability that we can do that AI cannot do, right? I really don't have answer to this question. But one thing that I'll be 100% sure, if I have to hire a person, even though the ChatGPT can do most of the work or Claude can do most of the work, but if I am presented with the choice whether to hire a person with the max or whether to hire a person without max, I will obviously prefer the one with mathematics knowledge. Of course, it's true that most of the mathematics and stuff is even done by ChatGPT these days, but not everything. But it pretty much it does pretty much you're really close. But that doesn't mean that it essentially erase the difference between people who know mathematics and people who don't know mathematics. The industry is always going to prefer people who are in the know-how of things. So I would say just learn the fundamentals, and you will definitely be able to stand out.
Thank you so much, sir. I will learn the language of mathematics and see it everywhere. I hope I will, sir. Thank you so much, sir. Thank you so much for a
Yeah.
valuable session, sir.
Thanks for the question. Yeah.
Good morning, sir.
Yeah, please. Yeah.
Sir, my name is Junaid Hussain
Yeah.
from Triple E Department, third year, sir.
Yeah.
I have a question for you, sir.
Yeah.
Name 3 engineering fields that use calculus, sir.
Of course, every I mean, in mechanical engineering, how could you really do something without calculus? And it's there right from calculating your rate of change. In fact, even in AI, calculus is everywhere. It's not, see, there is something called closed form solution, and there is something called an applied form, okay? People don't write mathematical equations like the way we do in school and colleges. But as you guys may be familiar, there is a concept called gradient descent and backward propagation. These are all based on calculus concept. The gradient, the backward propagation, which is the backbone of transformer architecture, is essentially just a chain rule. It is just instead of 2 variables, you are dealing with 1,000 variables. That's the only difference. So calculus is everywhere. So it's not, say, for example, it's not exactly calculus, but trigonometry, analytical geometry, these are things we do all the time. For example, I deal with the companies which do vehicle route optimization. In vehicle route optimization, it is very important that you have foundational knowledge on trigonometry, spherical geometry to do a lot of stuff. Okay, so it's all there. It's all yeah. So maybe just see there's another aspect to it. Not every software company deals with mathematics. You don't have to be a math guy to be successful. I told you right from the beginning. But we do a lot of things that are mathematics based. Many of the projects come to us when people give up, saying it is not possible. So we are able to survive, and we are able to expand, and we are able to contribute only because we were good at mathematics. So I'm telling all this from my own experience. So yeah.
Okay, sir. Thank you so much, sir.
Yeah.
Good morning, sir.
Yeah.
Sir, could you please share the presentation, sir?
The presentation is there in the web. So I shared with the Professor Balasubramaniam also. So you can just, whatever is in the URL, you can just take it. It's there in the URL. You can just download it also. Yeah. So
Okay.
anybody,
Okay.
yeah.
Thank
It's not in my desktop. It is there in the web. So you can just take it.
Good morning, sir. I'm
Okay.
audible.
Yeah. Please go ahead. Yeah.
So I am Mohammad Asik from BTech IT.
Yeah.
And I have a question for you. With the AI and advanced software doing many calculations, why is it still important for engineers to learn mathematics, sir?
Yeah, it's a very similar question. See, you guys may be using ChatGPT, and we also use Claude and ChatGPT. But what AI has done is instead of we taking 2 weeks to do a job, it is possible for us to do in 1 day. But that doesn't mean that somebody who have absolutely no knowledge of mathematics can excel in ML or AI or in a lot of engineering discipline. AI has made it possible for you to do things in 2 days, which earlier took 2 months or maybe 1 month. So it has really reduced the needed time, but that doesn't eliminate the need for you to be smart, intelligent, with all those math and foundational skills. Because you can't really ask proper questions to chat GPT if you really don't know mathematics. If you are really dealing, if you are into math, AI, and all these stuffs, in order to ask questions, you have to know you should have a certain amount of information and knowledge. So AI won't be able to do everything. Earlier I told you, even if AI is able to do a lot of stuff, I, as an entrepreneur and as an employer, I would always prefer someone who knows mathematics for the same job, which the AI may be able to do 80% of the time. But I would still prefer the person with mathematical skills.
Thank you, sir. Thank you, sir.
Yeah.
Good morning, sir.
Yeah. Good morning.
Sir, I'm Jabastan from third year EEE.
Yeah.
I have a question, sir.
Yeah.
So, what is the purpose of mathematical modeling, sir?
See, what is the purpose of mathematical modeling? So what the ability to just look at the world and reduce it to formulas, functions, or some mathematical transformation. Once you do that, manipulating that becomes easy because we have certain rules to manipulate mathematical model. So you do mathematical modeling only to simulate the real world in terms of mathematics. Because what mathematics gives you, it gives you the ability to manipulate, do some processing, do some operations, right? So you won't be able to do that in real time. Say, for example, would you be able to simulate earthquake? You won't be able to do it. So what you have to do mathematical. You have to come up with a mathematical model. Of course, every day civil engineers do that, AutoCAD and all that, right? In some ways, they are only doing a mathematical modeling of reality, right? Because reality, you really cannot afford to cause all the accidents and do all the testing in real world. So you create a mathematical model and do it. I think that's what you asked. So we do mathematical modeling all the time because we don't have the luxury of dealing with the real world. So we do a lot of mathematical simulation and solve a lot of problems.
Thank you, sir.
Yeah.
Sir?
Yeah, please.
Good afternoon, sir.
Yes, yeah.
I'm Ahmed Fayal from 38 EEE.
Yeah.
And my question is, what is the difference between pure and applied mathematics, sir?
See, for example, what used to be pure, see, the distinction is very clear for academic, from an academic circle, okay? But for somebody who's using mathematics in everyday life, I don't deal with complex analysis, for example. I don't deal with real analysis, okay? Because they are all abstract concepts today, but who knows, it will become applied mathematics later on. When people start using applied mathematics, when they find a real use case, when they apply it in their day-to-day life and they are able to relate it. But many of the abstract concepts later became like a real applied mathematics. Complex number is one example. Everybody thought it is just an abstract concept, but complex number is everywhere. I mean, it's there in your electrical analysis, so many places you have it, right? So there is no fixed concept, fixed thing like this is always going to be an abstract math area or a pure mathematics. There is nothing like that. The things keep changing.
Okay, sir. Okay, thank you for it.
By the way, I'm still an engineer, a software guy. Okay, I do a lot of mathematics stuff, but I just want to warn you, saying I don't have answers for all these mathematical questions because I don't have a proper mathematics degree. Okay, I'm just a mechanical engineer, ex Sathakian. So I know a lot of applied mathematics because I use it, but beyond certain level, if you ask me a lot of mathematics, even I may not be able to answer it.
Okay, sir. Thank you for the answers.
Yeah.
Good morning, sir.
Yeah. Please.
Sir, I'm Mohammed Nizamuddin from EEE department.
Yeah.
Could you please explain the role of statistics in maintaining the quality of the product to reduce defects?
You do a lot of p-value analysis, right? You have a lot of hypothesis and all these things, right? Hypothesis testing.
Yes.
Yeah. and people use naive bias algorithm. That's all based on statistics and probability. Do you guys know the difference between statistics and probability, by the way? This ties back to my earlier slide. Sometimes we read a lot of things in deep without understanding what the subject is about. For example, I mentioned about analytical geometry and discrete mathematics. So my question to you is, do you know the difference between statistics and probability? Say, for example, you had to explain this to a layman or somebody who is really not into mathematics. I mean, you don't have to answer it. I'm just asking you, do you know the difference between statistics and probability?
Yeah, sir. I think I know, but could you please explain it?
Yeah, so this is not a textbook answer. A mathematician may not agree to what I'm saying, but statistics is all about analyzing things that have happened in the past. Okay, somebody took a sample and all that. Probability is mostly about future, how things will happen. Okay, so in a nutshell, you can say statistics is about analyzing the past, and probability is about predicting the future. This is not a textbook answer, but this is my understanding of it, and most of the applied people who are into this field will agree to what I'm saying. So again, my point is, if you understand it in this way, then these words will no longer seem magic to you. Statistics is about the past, probability is about the future. These are very simple way to understand. If somebody asks the difference, I don't know whether it answered your question, but this is how I understand things. Okay.
Okay, sir. Thank you, sir. Thank you for your time, sir.
Yeah.
Good morning, sir.
Yeah.
I am Santosh from third year Provility department. I have a question, sir.
Yeah.
What software tools use mathematics in engineering, sir?
Okay, so this is a very pertinent question you asked. I really don't prefer to suggest you any tools, libraries, or any software, okay? Because I'm not that kind of a person. I always want to understand from first principles. There was a slide in my talk that says you have to go by first principles, especially when you are in college. You can do your own side projects using frameworks, but frameworks will come and go, okay? Every day people will release new frameworks. So if somebody says you don't have to write any, you don't have to understand anything on ML, there is something called Hugging Face. Just copy 2 lines and it will work. Okay, it's fine. But since you did not understand anything, it didn't really make a big difference. Okay, so from a career perspective, so my advice to you is, once you are in the job, you want to have a framework, because it speeds up things, it lets you complete things in a faster manner. But don't try to learn frameworks and libraries. Stay close to the basics. Try to learn Python and PyTorch, basic stuff. So don't go with the app builders and frameworks, at least when you are in college.
Okay, sir. Thank you, sir.
Yeah.
Good afternoon, sir.
Yes, Maya.
I am Mohammed Mujahid from third year EEE.
Yeah.
I have a question, sir.
Yeah, please.
What is the relationship between mathematics and technology?
You apply, no, there is no big I won't say it's technology. Okay. What's the difference between mathematics and technology? See, you use mathematics to solve real world problems, right? And real world problems are engineering problems. And that's what you mean by technology. So mathematics is just a tool to solve technology problems. That's how I understand things. That's my own way of saying it. Yeah, I don't have any textbook definition or answer to this.
Okay, sir. Okay. Thank you, sir.
Yeah.
So, good morning, sir.
Yeah.
So, my name is Sini Plover, sir.
Yeah.
Sir, in engineering mathematics subject, in every question paper, there is a question called find out the eigenvalue and eigenvector.
Yeah.
So what is how the eigenvalues are useful in engineering applications?
You asked a very, very good question. I'll try to answer it, but I don't know whether, okay, I'll just try to answer it. Say, for example, you are dealing with a machine learning problem, okay? And in that problem, you have a table with the Excel with 1,000 features. 1,000 features in the sense, for example, if somebody asks you, can you predict rain or can you predict yield tomorrow in agriculture? What are all the factors that you will consider? You will consider the wind, the humidity, the soil strength, the rain flow and all that. So these are all called dimensions, right? These are all called dimensions. Like this, in real world, people will have thousands of dimensions, okay, to represent something called a feature. Now, all these 1,000 dimensions are not really needed. Some of them are intercorrelated. Intercorrelated means if something goes up, the other thing will also go up, or other things may go down. They may be negatively or positively correlated. But the fact is, you have to deal, somebody will come and tell you, these are 1,000 factors that you need to do in order to predict. But if you really dig deep into it, you don't need 1,000, you only need 10. Okay, so now how do you figure out you need only 10? Then you go for something called principal component analysis. There you have something called SVD, and then SVD is again another decomposition, and eigenvalue also is another decomposition. It actually helps you essentially do something called dimensionality reduction. Okay, these are very heavy terms. In simple terms, dimensionality reduction is you don't need 1,000 you don't need 1,000 dimensions. You only need 10. And this dimensionality reduction problems helps you to identify those 10 dimensions. And the way you do it is using all this singular value decomposition and eigenvalue decomposition through a process called dimensionality reduction. Okay, but this is a very intense question. Yeah, but anyway, I hope I answered your question.
Okay, thank you, sir. Thank you very much.
Good morning, sir.
Yeah.
Yeah, so myself Javasilan, so I'm a pre-final year student, sir. And this whole session gone about maths and all. So it may be a variant question. So as a student from a technical domain, so as a founder, what are the skills and technologies or knowledge that you would expect to hire as a person, maybe as a developer or any technical person?
This was the question I was actually expecting somebody would ask. Glad that you asked this question.
Yeah.
Okay, very good.
Yeah.
The way that I hire in my company is, we have a small board. Okay, we don't care about your resume. To be honest, we don't care about your marks. Okay, please don't get me wrong. I'm not saying marks are not good, but I'm telling you, we expect people to have some good marks, which is always an advantage. But the way that we hire is, we just give you a small pen and we'll ask you to go in front of the board and just try to solve it. And 90% of the time, most of the candidates won't be able to solve it, and there's nothing wrong in it. You won't be able to solve it 90% of the time. But this is how we test people. We test people to see whether they are willing to take on the challenge, whether they are willing to stand in front of people and try to understand, ask good questions. We don't expect the candidates to solve it. We only care about whether they are able to follow the process, withstand the pressure, and ask the right question. And if they are really good at it, we will ask them to write few lines on the board. That's all. Most of the time, that is how we hire people. Okay, no fancy group discussions. Okay, that's not how I do. I also don't give a lot of importance to communication skill. I give some importance to communication skill, but that is not something I give a lot of importance to. But service companies do, but I don't do that much, because these days I have found even my own team members, they use all this ChatGPT and all other live real-time translation tools using MS Teams. They're able to converse with the customers freely. Okay, so that conversation skill, all these things are have enabled. But it's good to have communication skill, but that is not the most important thing I look at it.
Yeah, I got it. Okay.
But if you want to go to service companies like HCL, Infosys, TCS, that is the most important skill. I don't think so. They will ask you all this single value and all this.
Yeah, I understand. So as for you, you're using Max as like a screening process for it.
Yeah, exactly. Right.
Yeah, I got it. Okay. Yeah, thank you, sir. That's all.
Hello, sir. I'm Prasad from Chemical Department. Sir, my question is, we learn many mathematical concepts like differential equation and numerical methods. How do we know which topics are they truly important for a future career?
We don't. But let me tell you what happens when you read all these differential equations and Fourier transformations. Okay, there are real studies that tells you if you learn mathematics well, it physically changes the shape of your brain. It is not an abstract concept. Learning mathematics physically wires your brain in a different way. So you really become very smart. No, that is the most important skill you must have. It's not how much you know matters. It is how fast you can learn matters. And mathematics primes your brain for that. You get my point? If you learn mathematics, it primes your brain. You really don't want to learn a specific subject so that you will get a better job. That's not how you look at mathematics. Mathematics is something like you are training your brain, you are priming your brain. That's how you must look at it. But to answer your question, you talked about differential equations, right? So when you are doing differential equations, you would have obviously come across Laplace transformation and Fourier transformation, right? I don't know, you may have come across, but don't get intimidated by all that, okay? So this Fourier transformation is something that you guys know. It's all in signal analysis and wave analysis and audio analysis. This is something I don't know much about it, but even that I am currently using it in something called text to speech, okay? The text to speech uses something called spectrogram, and that is how you get all the voice audio snippets out of it. So we are already using it's in speech to text. Yeah, we're already using speech to text spectrogram, which is essentially based on all this Fourier transformation and all that. It's all involved. So it is very much there. It is very much there. Okay. So, but you don't basically pick a subject just because you are going to get a job later on. But that you may have to do that once you come out of the college. But now, as I said, you are in college. Just strengthen your basics. Just be a broad guy. Just get into all the topics. Connect all those disciplines, and then once you get into the job, you can become a real expert by just focusing on a specific field. This is not the time for it. Say, for example, if you're really good at mathematics, sorry, if you want to do robotics, for example, if you want to do robotics, and if you're really passionate about it, then obviously linear algebra, the transformation, kinematics, inverse kinematics, all are based on this linear algebra concept, matrix and vector and transformation. You can say, okay, I just want to do this, so let me get into this. So now you can pursue that career. Okay, if you're really passionate about, and if you want to do something in robotics. But in general, I would recommend that you be a you don't want to get deep into one subject. Okay, just get all relevant knowledge from all the categories. Okay, yeah.
Well, thank you, sir.
Ashraf sir, really very happy with your presentation, especially with your question and answer session.
Okay.
As a moderator, really, I am very fortunate to be here to see such a wonderful alumni who post their LinkedIn as a product of Muhammad Sadek Engineering College rather than Kamarajar University. Really, we feel very proud and blessed, sir. May God Almighty bless you and shower His abundant mercy and infinite love upon you and your family and your business forever and ever, sir. As a Sathakian, we are all really very proud. On the outset, I really thank our management, especially our principal, Dr. Nirmal Kannan, sir, and overall alumni organizer, Firdaus, sir, for this wonderful arrangement. Otherwise, we missed the wonderful opportunity, sir. Before your session, our people treat the mathematics as a bitter gourd, but now I ensure that we going to see as a sweet potato now.
Inshallah. Oh, good. I'm very happy to hear your kind words. And again, want to thank your principal, Dr. Nirmal Kannan. He actually called me 2 days back and personally invited. I'm really glad, really happy about it. It's an honor and privilege. In fact, it's a bit emotional also. You guys don't know what I am going through. Okay, so it's a bit emotional. Not now, but when I started it, I felt a bit emotional. I really felt that as if I'm really going back to my college days. So yeah, I'm really happy that your management did this, and I'm looking forward to a lot of these interactions. Okay, I'll try to do as much as possible from a working professional perspective, how I can do something back to my alma mater.
Sure, sir. As a token of love and appreciation, I cordially invite our alumni coordinator, Professor Balasubramanian, sir, to honor our chief guest with the appreciation certificate.
Good afternoon, sir. Sir, we sincerely thank you for the time you allotted for us and share the wonderful knowledge with our students. Definitely, it will inspire our students in a great manner. As a token of love and appreciation, it's my pleasure to present you the certificate of appreciation on behalf of our institution and our principal. It will be in one question, sir. And please find the soft copy of the certificate and we will provide you the hard copy in a good another day, sir. Thank you very much for your support
Yeah,
and your knowledge sharing, sir.
I will put up this on the wall of my room, so anybody who comes and meets me, they know. The more people will come to know, sir. It's not that I have to do this, but it is my own small way of doing it, just giving back something.
Thank you.
Thanks, Professor Balasubramanian. I again want to thank Dr. Nirmal Kannan and Dr. Firdaus also for putting all these things and bringing us all together. It's a really great to connect with you all, to be honest. Yeah.
Thank you, Ashraf. Thank you, Ashraf, for your time. And it's emotional bit as well, because we are connecting together. And we are always proud to be a Sathakians, and always we would like to continue the legacy of like a Sathak Institute as well. So we will draw together. Thanks for your time, and because I would like to buy this book, as you said, Super Simple Mathematics by DK Publishing. So definitely I will buy for myself and to explore.
By the way, there are a lot of soft copies available, but I generally don't go by it. I deliberately didn't choose to put it. You can find soft copies, but I generally pay book and buy it. Once I buy it, I may get a printed copy, but that's the reason why I didn't put the PDF link.
Yes, I will. Yeah, I will contact you. Then I will get this book as well, sir. Thank you, sir. Thank you, Asif, and everyone. Yeah, thank you.
Thank you.
Sir, let us come to an end. In Arabic, the famous dialogue is there, Askarulillah wa Askarullinas. மனிதருக்கு நன்றி சொல்லாதவோ இறைவனுக்கு நன்றி சொல்லாதோ ஆக முடியாது. So by these beautiful words, as we came to an end of this enriching program, I cordially invite our second year EEE student, Ms. Muzna Bibi, to propose the vote of thanks.
Good morning to everyone. It is my privilege and honor to propose the vote of thanks on this memorable occasion. First and foremost, I express our heartfelt gratitude to our honorable expert speaker, Engineer Ashraf, for taking the time to be with us today and sharing such valuable knowledge, experience, and insights. Your inspiring words have enriched us and will certainly motivate us in our academic and professional journey. Thank you, sir, for your gracious present and enlightening session. I extend my sincere thanks to our respected management for their constant encouragement and unwavering support in organizing programs that enhance all the learning experience of our students. My heartfelt gratitude goes to our respected principal, Dr. Nirmal Kannan sir, for his visionary leadership and continuous motivation that makes such event possible. I would also like to thank our respected Vice Principal Dr. Sendil Kumar sir for the guidance and support extended throughout the organization of this program. A special word of thanks to our respected Dean Dr. Dravida Shelvi ma'am for the encouragement and academic leadership that contribute to the success of the event like this. I sincerely thank our alumni coordinator, Professor Balasubramanian sir, and overall alumni organizer, Muhammad Firdaus sir, for their dedicated efforts in planning and cooperating the program and strengthening the connection between our institution and this alumni. My appreciation goes to all our respected heads of departments for their valuable and support cooperation in making this event a great success. I extend my gratitude to all the faculty members, organizing committee members, volunteers, and the technical team of their hard work and commitment behind the scenes. Finally, thank all you students for your enthusiastic participation and active involvement, which truly added life to today's program. Once again, thank you all. Thank you. Have a great day.
Thank you, guys. I look forward to connecting with you again. Thank you very much. Thank you.
Thank you, Ms. Na. Thank you, sir.
Thank you. Thank you very much, sir.
Thank you all. Bye-bye.